In this video, we are going to learn how to apply chain rule to do differentiation. Let's start with an example. Suppose we have a function called hx and it is equal to 5x squared minus 3x plus 7 to the power 6. What should be the derivative of hx? Of course, to differentiate this, we can just expand the whole power 6 bracket. But as we can see, doing this expansion will be very time consuming. And there is actually a simpler way to do this differentiation. It is to consider the chain rule. The chain rule states that if a function hx can be expressed as a composite function f(gx), then h prime x is equal to f prime gx times g prime x. This looks very complicated, but actually it is very simple and intuitive when we take a look at the dy dx notation. Suppose we let y be fu and u be gx, then that means y is equal to the composite function f(gx). Then to find dy dx, we just need to consider it as dy du times du dx. This is intuitive because it looks like we can cancel the du here, so that the result is just dy dx. Now we can try to apply the chain rule to do the differentiation in this case. We can let y be u to the power 6 and u be 5x squared minus 3x plus 7. Then y is a composite function and it is equal to the function hx that we are interested in. After decomposing this function into two simpler functions, we can see that both functions can be easily differentiated by the differentiation rules that we have learned. Now in order to find dy dx, we just need to consider it as dy du times du dx. And then dy du is just du to the power 6 du. And the du dx is d 5x squared minus 3x plus 7 dx. Both of them can be differentiated easily. This is not yet our final result because we want the result to be in terms of x, but not in terms of u. So we should substitute this back into u, and therefore it should be equal to this. This result is the derivative of hx that we would like to find. And this is how we can apply chain rule to do differentiation by considering a function as a composite function of simpler functions. The proof of the chain rule is rather advanced and it will be discussed in another video. In this video, we will focus on the application of the chain rule. Now let's take a look at other examples and see how we should apply the chain rule. This differentiation can actually be done by the quotient rule. But now let's take a look at another way to do this differentiation. In this example, we should consider y to be 1 over u and u to be x cubed plus 7x plus 1. We can see that both functions can be differentiated easily. And now dy dx is just equal to dy du times du dx. Then we can get that dy du is equal to minus 1 over u squared and then du dx is equal to 3x squared plus 7. We should do the backward substitution so that the result is in terms of x only but not in terms of u. Therefore, the result should be equal to this. Next, let's take a look at this example. In this example, we can consider y to be root u and u to be equal to x plus 1 over x minus 1. Then to find dy dx, it is just equal to dy du times du dx. For dy du, it is equal to minus 1 over 2 root u. And then for du dx, we can apply the quotient rule, so that the result is equal to this. After cancelling minus 2, the answer is equal to this. Please note that this is already our final answer and we should not do simplifications in this way. We should understand that when x minus 1 and x plus 1 are both negative, this function is defined because we're taking the square root of a positive number. However, these two square roots are not defined because we're taking the square root of a negative number. That means we should never split the root sign like this when we are not sure whether both the numerator and the denominator are always positive. Next, let's take a look at this example. In this example, in order to do the differentiation, we should consider y as a composite function involving three simple functions. The first function is the whole thing to the power 8, and we consider it as u to the power 8. And then the second function is the whole thing to the power 5 plus 3, and we consider it as v to the power 5 plus 3. and then the last function is simply 3x to the power 4 plus 1. Now dy dx can be written as dy du times du dv times dv dx. As we can see, to find dy dx, we can link dy to du, and then we can link du to dv, and then we can finally link dv to dx. It is just like a chain, and we can make it as long as we want. That's why this rule is called the chain rule. Now each part can be differentiated easily, and after doing the backward substitution, the result is equal to this. When we are familiar with the operation of the chain rule, then we can actually apply the chain rule without defining variables u and v. That means we can actually apply the chain rule in a more direct way. That means in this example, to differentiate this, I can first of all differentiate this function with respect to the whole thing inside the power 8 bracket. And then I can extend the chain by differentiating this with respect to the whole thing inside the power 5 bracket. And then I can further extend the chain by differentiating this with respect to x. And then I should end the chain here. Now I can do the differentiations one by one, and as a result it is equal to this. This is much faster as there is no need to do the backward substitution for u and v. Lastly, let's take a look at this example. In this example, in order to do the differentiation, we should apply the product rule. That means we should first of all take out this 2x minus 1 to the power 8, and then we should differentiate this by considering it as something to the power 7, and then we should further differentiate this 3x plus 4 to obtain this 3. And then for this part it is similar. We should first of all take out 3x plus 4 to the power 7, and then we should differentiate this by considering it as something to the power 8, and then we should differentiate this 2x minus 1 to obtain this number 2. As you can see, we can actually do differentiation in one step. After simplifications, it is equal to this. We can further factorize the result so that it looks simpler. This is how we can apply chain rule to do differentiation.